Hello and welcome to day 14 of Calculus in a Year. Today, we're going to be going over the derivatives of polynomials and that of constants. So here's how you find the derivative of a polynomial and of a constant. So, if I'm trying to find the derivative of a polynomial, x to the power of n, then the derivative, so the derivative with respect to x of x to the power of n would be n times x to the power of n minus 1. And if I'm trying to find the derivative of a constant, c, then the derivative with respect to x of c would be 0. And just so you know, n is a real number. So, let's say, this is just a quick note. D over dx, that's our differential operator, so it tells us to take the derivative. And on the top, we put our dependent variable. On the bottom, we put our independent variable. So if I were to have something like y equals x to the third, y is my dependent variable and x is the independent variable, and so that's why I write dy over dx is equal to 3x squared. If I were to have something like k is equal to x to the power of 3, I'd be writing dk over dx because k is the dependent variable and x is the independent variable. So you're always going to want to write your you're going to write your dependent variable on the top and the independent variable on the bottom. And if you don't have a dependent variable given, you can just write d with respect to whatever your independent variable is. In this case, our independent variable is x, and so you write x. If your independent variable happened to be something else, for example, if I had something like k is equal to y to the power of 3, I'd be writing dk over dy, and this would be 3y squared. So just remember that dependent variable on the top, independent variable on the bottom. And it's okay if you don't have your dependent variable, just write your independent variable on the bottom. So, find the derivative with respect to x of x to the power of 5. So please pause the video and try it out on your own. Alright, so the answer would be 5 times x to the power of 5 minus 1. So we have 5 times x to the power of 5 minus 1, that's 5x to the fourth. So, I didn't write any dependent variable here because I wasn't given a dependent variable. If I was given y is equal to x to the fifth, then I'd be writing dy over dx is equal to 5x to the fourth. So let's move on to the next problem. Find the derivative with respect to x of 9x to the power of 8 minus 4x to the power of negative 5 plus 15. So for this problem, you're going to have to find the derivative of each term individually. And so please pause the video and try it out on your own. Alright, so the derivative with respect to x of 9x to the power of 8 will be, it'll be 8, from this 8 right here, it'd be 8 times 9 times x to the power of 8 minus 1, that's 72 times x to the power of 7. Then the derivative of negative 4 times x to the power of negative 5, so I decided to take this negative down to here. The derivative of negative 4 times x to the power of negative 5 would be negative 5 times negative 4 times x to the power of negative 5 minus 1. That is 20 times x to the power of negative 6. And then the derivative with respect to x of 15 is just 0. The derivative of any constant with respect to any variable, that's always going to be 0. So the derivative with respect to x of 72 times x to the power of 7, I messed that up. The derivative of 9x to the power of 8 minus 4x to the power of negative 5 plus 15 that's going to be equal to 72 times x to the power of 7 plus 20 times x to the power of negative 6. So, yeah. So we're going to do some practice problems. And so please try them out on your own. And only unpause if you're done or you're thoroughly stumped. Alrighty, so here are the solutions. I'll reveal them one at a time. So problem 1, and then problem 2, then problem 3, problem 4, let me bring it up here, problem 4, and then problem 5. Alrighty, so that's it for today. Thank you for watching, and I hope to see you back soon.